Hey, welcome to this video on velocity as vectors. So we have a following problem to solve. As you can read the question, Mary leaves the dock and she's going at 30 degrees to the current. Her speed in still water is 3 meters per second, and the current flows at 4 meters per second. So in order to answer question part A and later part B, we need to know what is Mary's resultant velocity, which is influenced by the current. So yes, we did create a diagram which represents the river. The flow is from left to right, and the 30 degrees, please note, it would be in tail-to-tail arrangement. So her direction to the current defines the 30 degrees. So in this velocity diagram, where we want to find resultant velocity, the angle right there at this vertex is 150 degrees, which is the supplementary angle for 30. I hope this makes sense. So from the cosine law, we can find how fast Mary swims or paddles in the water with the current. So completing calculations, this is her speed, which will be used to answer part A and part B. So part A, how far downstream does Mary travel in 10 seconds? So in 10 seconds, she travels in the same directions, so we can find this distance, but actually part A is about finding the horizontal distance, because this is what it says, how far downstream. So we will work with a right angle triangle. But before we can answer the question, we need to find a certain angle in this triangle. So that angle, marked on the diagram here, is 12 degrees. How can we find the value of that angle? From the sine law. Look at the diagram which represents the velocities. So her speed in the still water, the current speed is horizontal, so our triangle right here can be solved for angle alpha at that vertex right there. Why do we need that angle? Because we have to find the one leg of the right angle triangle. We have to find the length of the horizontal. Working with a 90-degree angle, and that angle on the right hand side, we can define the value of d, which is the downstream distance after 10 seconds. So after 10 seconds, the distance that leads her to the right is equivalent to 67 meters, 0.664. Now using the cosine ratio for the right angle triangle, we can find the value of d. And there you go. So this is the answer to part A. Okay, so part B. We have to find the length of time required to cross the river in that direction. So the direction now is known. So the angle with the horizontal is 12 degrees. And we have to find the time required to cross the river. And the total width of the river is 150 meters. So what can we do? First, we have to find the length of that hypotenuse. So we label it as A. So using the sine ratio, we can find the length of that distance A. So knowing that the distance is 676 meters, and also knowing that her speed in water is now 6.7 centimeters per second, we can find how fast she will go from the start to the end, just simply by dividing a by velocity value. And this calculation gives us 100 seconds, which is 1 minute and 40 seconds. So there you go. We solved part B. So I hope you found this video useful, and I see you next time.